I want you to write down the problem that we were doing. X plus y equals 7. And 4x minus y equals 3. Now, you are welcome, since they are both lines, you are welcome to put both of them into slope-intercept form. However, I don't think that is always going to be our most efficient way. Okay? Especially because we could be working with fractions, which is fine. Fractions are fine. But sometimes fractions can get frustrating. Especially if it's not the only way we have to do it. Okay? So I want to encourage you to go with more along the lines of what groups 7 and 8 were doing. Pick one equation and pick one variable and get it by itself. Okay? It does not matter which variable that is. So just to be a little bit different, let's choose x in the first equation. If I choose x in this first equation, then I can write x equals 7 minus y. Do you agree? Because I subtracted y from both sides. Okay. Well, if I have x equals 7 minus y, then I can come down here and I can say, okay, well, 4x minus y equals 3. But instead of x, we can substitute 7 minus 1. How do you feel about that? Okay. Joey, you're okay with where I got the numbers? So from here to here, we're solving the literal equation for x. Okay. So now let's go ahead and distribute. So we have 28 minus 4y minus y equals 3. Okay, got to combine like terms. 28 minus 5y equals 3. When we subtract over the 28, what do we have over on the right side? Negative 25. So what does y equal? Y equals 5. Okay, well, if y equals 5 and x is 7 minus y, what's x? 2. Is 2 plus 5 equal to 7? Mm-hmm. Is 4 times 2 minus 5 equal to 3? Okay. If you solved for y and substituted it in, would you get the same thing? Yeah, you would. Okay. Okay. I just want to talk about that real quick. Okay. If I would have solved for y equals 7 minus x, and I went into 4x minus y equals 3. If we go in and replace y, do you see how there's a minus right there? You always need to be substituting using parentheses because that minus is going to affect the 7 and the minus x. Do you see that? How this becomes 4x minus 7 plus x equals 3? Okay, so every time you're substituting, I want to make sure that you are substituting using parentheses. Okay. All right, let's do another problem together. Let's do x plus 3y equals 12. 2x plus y equals 9. I think one of my favorite things about this particular topic is that we are always going to have options, okay? Even within the method that we're doing, okay? So I have two linear equations. I know that they're intersecting at a coordinate, okay? Since we're using the method of substitution, I can choose one equation and one variable I want to solve for. But let's make our work efficient and not stressful. So who has an idea of what we could solve for in one of those equations to make our life smooth? M, what do you think?
Y in the second equation?
Okay, could we easily solve for y in the second equation? Yeah, we could solve for y in the second equation. What's another nice option that we have?
Subtracting 3y in the first equation.
Okay, we could solve for x in the first equation and then substitute. Doesn't matter which one you pick. It does not. Okay, if you wanted to, you could solve for x in the second one. It'd be a little bit more work, but you still could do it. It doesn't matter what you choose as long as you do it correctly. So let's vote. How many of you would like to take the first equation and solve for x? How many of you would like to take the second equation and solve for y? Okay. I think I had more people opt for the second one. If you want to go rogue and you want to do it your own way, well, I do it this way, I can't stop you. Okay? So if I rewrite this one by subtracting 2x, we get y equals 9 minus 2x, right? So I can take our first equation, x plus 3y equals 12. I can erase y and replace it in parentheses with 9 minus 2x. So we get x plus 27 minus 6x equals 12. Does that look right?
No, not yet. Because we need to combine like that.
Right. I'm just making sure you agree with my math. That I did that right. Okay. So you ready for me to combine like terms? Okay. So we have negative 5x plus 27 equals 12. What happens when we subtract the 27 over? Negative 15? Ah, well that's nice because x equals 3. Right? And if x equals 3, I can come back up here to y equals 9 minus 2x to get that y is 9 minus 6, which is 3. Again, the beautiful thing is x plus 3y. 3 plus 3 times 3, does it equal 12? 2 times 3 plus 3, does it equal 9? So we got the right answer. Okay, so this is what I want you to do. We're going to do things a little kind of weird. I want you to turn to page 141. Your homework is 10 through 19. Now, in about, I don't know, 10 to 15 minutes, we're going to take a time out and we're going to talk about what happens when we encounter a word problem like number 19. But what I want us to do first is I want us to take some time to start working through some of these problems. Now, number 10 is very similar to what we did in class today. What about number 11? What is that similar to? Number 11 is similar to what we did yesterday. Number 14, very similar to what we did yesterday. Okay? So I want you to go ahead and get started on number 10. And then in about 10 minutes,